All right, let's practice some more. Can't get enough of this. Keep practicing. Practice, practice, and practice some more. We're going to find the derivative of y is equal to the tangent of x plus 10 to the 21st power. Dun, dun. It's no big deal, right? We still have outside and inside functions. It doesn't matter what exponent you put on there or what you put on the inside. It's still just on the inside. So y prime is now equal to the derivative of the outside. So bring that 21 in front. Keep the guts. Times the derivative of the inside. Now what's the derivative of tangent? If you don't know it, learn it. That's important. Remember I said you got to know these. Anything we learned in the past is fair game now. And you know I like me some trig. So I'm going to be putting that everywhere I possibly can. Good. The derivative of tangent is secant squared, and the derivative of a constant is just 0. So that's just straight up secant squared. Cool. Are you guys hollering at me? Oh, I'd be so impressed. I'm so impressed. I put a 2 there, but that's not my exponent. 21 should have come in front. Good, good, good. I'm so glad you guys are on it. I'm so impressed with you. 21 secant squared x times tangent x plus 10 to the 20th. Now it's all multiplied together, but it's just good practice to put those as a coefficient if they're multiplied out there outside of those parentheses. All right? Okay, let's do another one. Now, who's to say that I don't have more than one inside function? Ooh, yeah, that's right, y'all. We're getting spicy. Ooh, we're getting spicy. Try this one on. Y is equal to sine of cosine x squared. Check us out, right? Check us out. I have the outside function of sine. Then when I'm looking at this, I have an outside function of cosine. Then I have my total interior function of x squared. There's no problem with that. You can do the chain rule as many times as you need to. You could do it 50 times. It don't matter. If I'm looking at this, you can do the chain rule and the chain and the chain. This is a double. But the process is the same. That's why it's a process. Because you could apply it to anything. It's not a formula. It's a process. So you can apply it to anything. It's not just a straight formula. Okay. Derivative of the outside. So what's the derivative of sine? Cosine. And remember, what are we doing? Keeping the guts. So you keep cosine here of x squared times the derivative of the inside. When I take the derivative of the inside, I have another outside function. Yeah, you see that? So what's the derivative of cosine? Negative sine. Keep the guts. Keep those guts. Then I have another chain rule. Right? So it is so important to recognize what an outside function is and what the inside function is. So you know how to keep those guts of the inside function. Just work in terms of the outside function each time till you work your way all the way in and there's no more inside function. Okay. Now let's just clean this up a little bit. Notice how I put parentheses around this. If you don't, it looks like a minus sign. We're not doing that. This is multiplied. All of this is multiplied. So we're going to bring our coefficients in front just because it makes us feel good. 2x and keeps us organized, more than just that, of the sine of x squared times the cosine of cosine x squared. And we just leave it like that. Neither one of these cosines are inverse functions, so it's okay just to leave it like that. All right. All right. What kind of room do we have left here? Oh, I think we're going to need a little bit more space for this next one. So let's come on over. Come on over. Come on over, baby. y equals x squared times the square root here of x squared plus 1. Tell me things that you see. Good, I have a radical, so what do I automatically have to write? Yes, x squared plus 1 to the 1/2 power. Change that to that exponent. Okay, tell me more things that you see. Ooh, right? This is an x squared. Didn't mean to do that. This is an x squared and an x squared plus 1. I have variables in both of these. So we have the product rule. Yeah, right? Look for those variables. Where do I have variables? They're multiplied together and I have variables in each piece. If this had just been like a 2 by itself, that's just a coefficient because it's just a number. But as soon as I put that variable in there and something that's multiplied, that's whenever we get the product rule. Okay, well, let's do the product rule then. Y prime is equal to the derivative of the first times the second plus the first. Now check out what's happening. When I take the derivative of the second, what do we get to do for the derivative? Chain rule. Yes, outside function. Bring the 1/2 in front because it's a power rule. Keep those goods. Subtracting 1 from the exponent gives me a negative 1/2 times the derivative of the inside is a 2x. Now this whole term is multiplied together, which means I've got a 1/2 times 2. They cancel. 1/2 times 2 is a 1, right? Now just clean this up a little bit. Y prime is equal to 2x times x squared plus 1 to the 1/2 power. And then I've got plus x cubed and x squared plus 1 to the negative 1/2 power. Let's think. Have we seen something like this before? Maybe at the very beginning of the semester? Maybe the very first thing that we looked at? Factoring, y'all, factoring. Did you see this? I've got this term and I've got this term. Do they have anything in common? Yes, they do. We get to factor. Oh my goodness, there was a reason why we practiced that. And here it is. Here I've got an x in this one and an x cubed here. So we can factor out an x. I've got the exact same thing in parentheses. Take out that lowest exponent. Good. So that's x squared plus 1 to the negative 1/2 power. What's left over here? I've got my 2. And remember, whenever you do the, let me change my color. When you factor, you divide. So when you divide, you subtract exponents. So this is minus a negative 1/2. Add the opposite. And I've got x squared plus 1. Yes. All right, plus here I've got an x cubed, and I'm going to factor out an x, so that just leaves me with an x squared. And here I've got this whole thing is factored out, so we're good with that. Now clean it up. Y prime is x times x squared plus 1 to the negative 1/2. 2x squared plus 2 plus an x squared. Combine those like terms. Y prime is equal to x times x squared plus 1 to the negative 1/2 and 3x squared plus 2. You look and see, is there anything else in common? Is there anything else I can do to simplify or factor? And no, there's not. Cool, right? See, factoring is handy. It's handy, especially when we're doing the chain rule, especially when you combine it with the product rule or the quotient rule. There's going to be lots of good things to practice here, right? Oh, algebra, you sweet, sweet little tool that we can use. Oh, how we love you so. All right.